Greetings everyone, this is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next in our series of what to look for in the night sky. This time we're talking about the week of October 24th, 2022, the last full week of October. As usual, as has been the case lately, we've got disparate things to talk about, several things. We want to jump right to it. We got a lot of things we want to cover here. And also, as usual, we want you to think about a couple of things. Enjoy the night sky for the beauty that it is, but it's good to think about these things and what they're telling us as well. So we got a couple of those things we're going to look at, and another long-term observing project, one I recommended to you a few weeks ago or a month or two ago, and you can continue here now. And so, it's as I tell my physics lab students, when we're going into physics lab, what's the most important skill you can develop in the laboratory, the most important thing you can do in the laboratory, and that's think. To say, that it's great to develop skills with instruments, it's great to develop skills with data analysis, it's great to develop computer skills, and it's great to do all of those things. And it's really important to be able to set up a good experiment, to make sure you're careful with the equipment and you know how to get things aligned, you take the time to do things right. But none of that replaces thinking. You got to stop and you got to think about what you're doing, why you're doing, and what you're seeing is telling you. And you can apply that to the night sky. It's less important there because we're not out there doing experiments week to week trying to figure out the universe. But it does add a little layer of appreciation to what's going on out there. So with no further ado, let's jump right into it. We're going to start with Mars. We've been looking at Mars for a while now. And Mars is in Taurus, and we're going to look at a couple of things here. There's Aldebaran. We have the V of the Hyades right here, and then we extend it on out to a couple of stars that are extended out there. I've got that V open a little bit too wide, I think, on the board. It needs to be squished up a little bit that way. You can look at some photos out there. As always, you can go to our website and look at our photos of this region of the sky to see what we're talking about, and you can find others out there. Right now, Mars, big and bright and orange and beautiful and rising into the sky as it gets dark, as we turn from October into November. You don't have to wait long after dark to see Mars appear. You get out probably 8 or 9 o'clock and it should be well up into the sky by now. It makes a beautiful white triangle, about 16 degrees across there, about a fist and a half at arm's length. 16 degrees across from bright orange and red Aldebaran down to bright red Betelgeuse. So we've got 3 really bright red objects. Mars is the brightest. You'll see Mars sticking out, popping relative to those. And you got about 16 degrees and about 16 degrees or 17 degrees across there. And it makes this really beautiful right triangle with those 3 bright red objects. Now Mars has been moving, as planets like to do, has been moving east. When we first started tracking Mars a couple months ago, it was over here near Aldebaran, and it's moved all the way through this open V of Taurus right there. But it's about to stop that. It's about to go into retrograde motion. By the time our week is done and we head into the first week of November, Mars will start to track back that direction. What's going on? This is the Copernican revolution, right? Copernicus didn't change as much. When we talk about the Copernican revolution, he maybe didn't change as much as many people think that he did. What he really said was, what everybody was stumped by, what people were wondering about, what people were wanting to figure out was, why do planets do this? You could make a relatively simple model if planets always went the same direction at the same speed across the sky and tracked against the background stars at the same rate. There's a lot of relatively simple models. No models are as simple as they look like they're going to be on the surface. But you could build a relatively simple model. But Mars doesn't do that. The other planets don't do that. They stop and they go backwards. And in fact, if you start watching Mars now, you will track Mars back all the way over here by the beginning of January. Okay, got a couple of months of observing. Watch Mars go tick, 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 tick in January, and then start back this direction again and make what we call a retrograde loop. What Copernicus did for us was Copernicus said if the planets are orbiting the sun in circles like this, and the inner planets are going faster than the outer planets, even if they're not going physically faster. If the velocity is not faster, they're going angularly faster. They're going to complete a circle faster than the outer planets, but they are going faster through space too. Then that means the inner planets are sometimes going to catch up and pass the outer planets. So if we're here and Mars is here, as we see Mars against the background stars that way, as we catch up and pass it because we're going faster, we're going to see Mars moving backwards. Everybody's going this direction in orbit. And so Mars normally looks like it's going this direction, easterly through the stars, but as we catch up and pass it, it goes backwards through the stars and makes a retrograde loop. And now's a great time for you to think about this, what we call Western science, what we call science today, what people come to Luther College to study science. It starts to grow right here from this as we start to make models of the solar system and try to understand. We're modeling the universe in a big way. Now, it's growing up in other places and other things in other ways and has grown up in pieces before this. This isn't the sole beginning of this story, but it is a beginning of this story. And it's good to think about this, seeing the planets move backwards as you watch Mars start a retrograde loop at the end of this week. It's barely moving at all right now. Now, there's another great thing we want to do with Mars right at the moment. Mars sits about 2 degrees here above and to the east of a nebula, the Crab Nebula, M1. Now, the Crab Nebula is a supernova explosion remnant. It's a star that blew up. Nebulae could be all kinds of gas and dust from all kinds of sources and all kinds of reasons. But this star blew up in the year 1054, and we know that star blew up in the year 1054 because we have pretty good records of that supernova being big and bright in the sky at that position at that time. So records from China tell us that observers in China saw this supernova and recorded details of this supernova in the year 1054. And so it's a turbulent cloud of gas. Again, you go to our webpage and look at pictures. You can see better, more detailed pictures in other places out there. But what you want to try to do right now, if you've got a small telescope, it's only about 2 degrees from Mars down this way. It's a great chance just to start to scan down and right from Mars and see if you bump into a fuzzy little patch, a hazy little patch that looks like a fingerprint or a thumbprint on the sky as this cloud of gas. And if you have binoculars, if you have good binoculars, 750s or 1050s that gather a lot of light, there's a decent chance if you've got dark skies you might be able to see this nebula there as a little glowing patch. This is a star. Stars that tend to be maybe 8 times as big as the sun will end their existence in these supernova explosions when you have a core collapse, which we could go on and on and on about, and we would love to go on and on and on about breaking quantum degeneracy and the degeneracy pressure that goes on in the core, but we're not going to do that. And so instead, just know that this core collapse of the star, it rebounds, a shock wave rips out through the star, and that shock wave creates all the elements of the periodic table and spreads those elements throughout space. That shock wave hits clouds of gas and initiates new star formation enriched with those heavy elements, all the wonderful things we see around us created in that supernova explosion. And this is a beautiful example of one we know historically when it occurred, and you can see that supernova remnant, what's left over of that star that was disrupted when it blew apart. Now, not all stars that are 8 times as big as the sun or bigger will do this, because stars that big are shedding mass like nobody's business. They're blowing mass out into space and trying not for this to happen if they can get rid of enough mass. But somewhere around there, many of these stars will, and so you will see a lot of stars that do that. Now, there aren't that many stars that big. Most stars are, in fact, smaller than the sun, and so it's easier to make small stars, and small stars live a lot longer. And so there's a lot more small stars in the sky than there are big stars in the sky. And so we don't get a lot of supernova explosions. We haven't seen one for a very long time. It's been a few hundred years since we've laid eyes on a supernova in our galaxy. And so we see them all the time in distant galaxies. But that's a story for another day, another suggestion of what to look for. So that's what we got here. As we're looking at Mars, you want to look at 2 things. You want to see Mars in Taurus. Notice its red, beautiful color with Betelgeuse below and Aldebaran over to the right. These 3 big, bright red objects. Mars is the brightest. Mars is the brightest. And just below Mars is this Crab Nebula that blew up, a star that blew up 1,000 years ago almost now. And so appreciate that for what that is and think about what's going on there, but also think about Mars starting a retrograde loop and how that helped us start to unravel mysteries of the universe like stellar explosions and what stars are and how this can happen and how the chemical elements of the periodic table came to be and all of this wonderful stuff. And so start to appreciate that and track Mars over the next few months. Again, that's January, mid-January out here. Mars is going to be all the way back over, probably a little too far, but over this direction by Aldebaran, back that way. Okay, that's what we got. We're going to leave you with one more thing because we haven't used up enough of your time yet. And so by the end of the week, the moon will have gone through its new phase and started to make an appearance. On Thursday, it will only be about 8% full, and that's a pretty good challenge to see. But I'm going to recommend, for me, local time about 6:30, going out and looking west in the glow of the sun. Pair of binoculars helps. But an 8% moon is 8% full, very thin crescent. It's definitely a visible moon, a couple of days past new. And so a lot of times people who work at it can see it within 12 to 24 hours past new. And this is 48 hours past new. So you have a good chance of seeing that moon. By the next day, it's 15% full. And on the 29th, Saturday evening, it's 24% full, and as it gets dark, it should be very easily visible. It's tracking from Scorpius through Sagittarius as it does that. So enjoy the moon moving back into the evening sky. Look at Mars as it moves through Taurus, and think about the Crab Nebula that tells us about a supernova explosion that occurred a long time ago. And so that's what we got. We hope you have clear skies. We've had some pretty good clear skies here lately, and it's been fun observing. So enjoy it, everyone, and have a great week. And as always, thanks for watching.